Okay, here's the learning target. Solve exponential equations involving e and natural logarithmic equations. And to do this, we're just going to work through 5 examples. So let's go straight to the blackboard. Okay, here we go. Example 1. Find a number w such that the ln of 3w minus 2 equals 5. So we got ln of 3w minus 2 equals 5. Okay, and here we're set up just to use the definition of logarithms. That ln means we have a log base e, so we have e raised to the 5th equals 3w minus 2, and this is going to give that 3w equals e to the 5th plus 2, and w equals e to the 5th plus 2 over 3. Now that will work just very fine as a final answer. If you want to get a decimal for that, that's fine too. I just ask that you round to 3 decimal places. Okay, let's go to example number 2. Find a number y such that e to the 4y minus 3 equals 5. So let's do this. E to the 4y minus 3 equals 5. Okay, anytime we have a variable and an exponent, we want to use logarithms to get that thing out of there. So I'm going to take the natural log of both sides. You can do anything you want to an equation as long as you do it to both sides. It is the ln e to the 4y minus 3 equals the ln of 5. And of course the ln of e to the 4y minus 3, that is a composition of inverse functions which yields the identity function. So that gives me 4y minus 3 equals the ln of 5, which is going to give me that 4y equals 3 plus ln of 5. And for a final answer, I would leave y equals 3 plus ln of 5 divided by 4. Now again, that would be my final answer. I'm a math guy. You engineers, round it to 3 decimal places if that makes you feel better. Okay? Let's go to the next example. Example number 3. Let's solve for x. So we have ln of x plus 4 minus ln of x minus 2 equals 3. Now over here on the side, we know that the the ln of a over b equals the ln of a minus ln of b. So we're going to use that property of logarithms. We're going to go from this side to that side. So this subtraction here tells me I can rewrite this as the ln of x plus 4 divided by x minus 2 equals 3. And now I'm set up to use my definition of logarithms. So x plus 4 over x minus 2 equals e to the 3rd. Okay? And now something very fundamental. Anytime you have a variable in a denominator, you need to multiply both sides by that denominator to get the variable out of the denominator. We'll multiply both sides by x minus 2. So they cancel on the left side, and I'm left with x plus 4 equals e to the 3rd times x minus 2 times e to the 3rd. So now we're back to our early algebra, just getting all the x's on one side and all the constants on the other. We want to isolate x and get it by itself. So I have x minus e to the 3rd times x equals a negative 4 minus 2e to the 3rd. So now using the distributive property and undoing this common factor here, x and x, I say x times 1 minus e to the 3rd equals negative 4 minus 2 e to the 3rd. And now all that's left is to divide out by the coefficient of x. And we have our final answer. Therefore, let's say x equals what? Negative 4 minus 2 e to the 3rd all divided by 1 minus e to the third. Again, I'm happy with that as a final answer. The engineers among us round to 3 decimal places. Or if you're doing backyard carpentry, you'd probably want to round to 3 decimal places as well. Alright, moving on. I think we're on example 4 now. So let's solve for e. We have e to the, or solve for x, I'm sorry. We have e to the 2x minus 4 e to the x equals 12. And these are always tricky. You just have to see a few of them to learn to do them. I see that this is, I can rewrite e to the 2x as e to the x squared because of my properties of exponents minus 4 e to the x, and bring that 12 over. Minus 12 equals 0. And you want to see that this is, you can set this up as a quadratic. Let z equal e to the x. Then we have z squared minus 4z minus 12 equals 0. And now let's hope this thing factors nicely, because I don't have a calculator with me. Is that going to, yeah, I believe it is. Okay, so z, what, minus 6 times z plus 2 equals 0. 6 times negative 6 times 2 is a negative 12, and I add them together and I get a negative 4, so I'm good. And so this is going to yield that z equals 6, or z equals negative 2. But very key here, you do not stop. You were not asked, if you look back, you were asked to solve for x, not solve for a z. So we got to go back here and plug in the z's and get our x's. So when z equals 6, we have, what, 6 equals e to the x. And so, what, taking the natural log of both sides, I get x equals ln of 6. So that's one of my answers. And when z equals negative 2, we get negative 2 equals e to the x, which we know there's no power that I can raise e to get a negative 2. So this is not going to give me an answer, and I can cross that out. And so my only answer there is going to be x equals ln of 6. Okay, one more example to work through here. Example number 5. We have a quotient. 4 minus ln of w divided by 3 minus 5 times ln of w equals, oh no, equals 3.6. Again, I have no calculator on hand. Oh, yes, I do. I have my iPhone. Let's see, just to make sure. I don't want to play with these decimals and give you wrong answers. I'll pull out the iPhone calculator just to make sure I'm not. Okay, let's clear it out. Clear it out. Oops. Okay, so let's get to doing it here. So again, I need to get LNW by itself, so I need to solve for LNW, but there's an LNW in a denominator, so I have to get it out of there. So to get it out of there, I multiply both sides by the denominator. So multiply 3 minus 5 ln of w, and you can do anything you want to a math equation as long as you do it to both sides. Okay, so that leaves me with 4 minus ln w equals 3 times 6 is 18, carry the 1, 9, 10, it's going to be 10.8, and then let's go with minus 5 times 6 is 30, gives me a 0, carry the 3, 15, 18, so 18.0 ln w. So let me just check that. 5 times 3 point. Good. Okay, we're looking good. And now I want to get all of my natural logs on the same side. So I'm going to gather them on the left side, and I'm going to send my constants to the right. And so the negative 18 ln w goes over to the left, and I get a positive 18 ln w minus ln w equals 10.8 minus 4. Okay? So I've got 18 apples and I eat 1 apple. 18 LNW minus LNW. That leaves me with 17 apples. Equals 10.8 minus 4. What's that going to be? 6.8. And now I'm going to get that. I need to get LNW by itself so I can use the definition of logarithms to solve for W. So I get ln of W equals 6.8 over 17. And I'm not going to do any, I'm going to leave that alone for a second. I'm going to use my definition of logarithms and get that W. So therefore W equals e raised to the 6.8 over 17. And since I already have a decimal in that, it doesn't look as elegant as I would like. I'm going to go ahead and run this through my calculator and get an approximation of 3 decimal places. So W equals, let me see, where's my E at on here? There it is. E raised to the, and make sure you use your, after your caret, make sure you hit a parentheses before you put that quotient in the exponent. 6.8 divided by 17. These iPhones are really handy things. And E raised to 6.8 divided by 17, that's it. And I'm getting in a decimal approximation of 1.492. Rounding that, it's 1.4918, so I'm going to go with 1.492. Okay, and that will conclude this lesson. I hope this helps you guys out, and you girls too, ladies, I should say. I hope it helps you ladies and gentlemen out. All right, see you in class.